Well, hello everyone. Welcome back to Adrian's Digital Basement 2. This video is about the Acorn Archimedes. This is the machine right here, the keyboard, and we're going to be talking about the mouse. Essentially with this machine, the mouse connection is right here on the keyboard, and it has the same connector as a regular bus mouse. And by bus mouse, I'm talking about the Microsoft bus mouse that Microsoft released at some point in the 80s, early 80s. And while this machine uses the same connector as the Microsoft bus mouse, and this Logitech mouse happens to be a clone of that bus mouse, this is a PC mouse. This is not designed for use with this computer. Well, Acorn, when they designed this computer, they used the same connector and even the same signaling, but the pinout is not compatible. This particular Logitech mouse is exactly the same physically. It looks the same as the Acorn Archimedes mouse that came with this computer. And I think it's pretty rotten that they use the same connector, and yet the signaling is different. And I have a feeling if you tried plugging this mouse in without rewiring this, that it could actually damage the mouse, potentially. Now, this machine has been on a couple main channel videos, and what I've been doing is I've been using this particular adapter with this Microsoft optical PS2 compatible mouse. So the Arc Mouse USB. TrueMouse.com. I have no idea if this actually works with all USB mice or only ones that are actually PS2 compatible like this. This means this mouse could actually switch between USB signaling and PS2 signaling. And I know some of these adapters which just use a simple microcontroller, which I can't tell you what it is because the part number's been shaved off, but most likely that microcontroller is like an AT Mega or PIC or something and isn't necessarily compatible with actual USB mice, is really only compatible with PS2 mice. It just happens to use a USB connector. One of the issues with this adapter is I just hate how it connects up. So you get this aligned. The designer of this obviously was working within the constraints of the placement of the connector, the microcontroller, and the USB connector, and it resulted in it being offset like this. And well, at least on this keyboard, the whole thing is it's just not particularly great, and it falls out really easily. So what I want to do here is I want to try to rewire this mouse so I can use the same cable, same connector, and have this wired up so that it is compatible with the Archimedes mouse input. And going into this, I'm really not sure if this is going to be possible, so this video might be a failure, and if it is, I'll have to take a different tactic to get this converted over. All right, first things first, let's move the Archimedes off the bench. Okay, so first off, why is this mouse compatible with the Archimedes mouse? Well, it's compatible because the signaling this uses is called quadrature encoding. And you can always tell that when you look at the pinout, when you have two X and two Y signals, this A and B, or 1 and 2, depending on how it's labeled, are pretty much a direct output of the two encoders for X and Y that read the position of the wheel. Now, the reason why you don't just have one X and one Y signal is because the computer needs to know which direction the mouse is moving. And if you want to know more about quadrature encoding and why that's used for mice and all sorts of other signaling like rotary encoders, check out the Wikipedia article, which I'll link down below. And the type of signaling that the Acorn uses and this mouse uses is basically the same as all the various mice from back in the day. This is a Macintosh mouse, and it uses quadrature encoding as well. The Amiga and the ST also use quadrature encoding, and that really means with some rewiring, these mice could potentially work with the Acorn Archimedes as well. It's all basically the same, just with a different pinout. Of course, the one problem with the Acorn Archimedes, well, not really a problem with it, but the one problem with using a mouse like this, or an Amiga or an Atari ST mouse with it, is that the Archimedes uses all three buttons. Well, one button's not going to work, two buttons on the Amiga and the ST is not going to work. You really do need to use a 3-button mouse like this Logitech one, or any other PC mouse that has 3 buttons. Now, some bus mice, the later ones at least, they actually have a scroll wheel. And when you push on the scroll wheel, that's the equivalent of the middle button. And when you use it with the Archimedes, that'll work that way. And in fact, when I was using this mouse with the adapter, that's exactly how the wheel worked. Scrolling up and down didn't really do anything with this little adapter, but pushing on it definitely was the middle button function. And that is a little bit annoying because the middle button is highly used. It's a very often used function on the Archimedes RISC OS. So if you're going to try to do this conversion yourself, I try to recommend finding a mouse like this that actually has a dedicated middle button. So in preparation for this video, I went and looked for the pinout that would be used on this Logitech mouse, and it's going to be this pinout, the Microsoft Mouse Import Interface. Now, the reason why there are 2 here is just simply because the way the pins are numbered seems to be different, with pin 1 starting at the top versus pin 1 starting at the bottom. The signals are exactly the same. Like we look at pin 1 on this bottom chart, it says mouse button 2, pin 7, it says switch 2. So functions are exactly the same, just the location. That's not a big deal. Next, we have the pinout for the Archimedes. Now this says 400/1. I don't know if it's the same on like the 300s and the 400s. The version of the machine I'm using is the 420/1, so I guess this is the appropriate socket. Now we notice that this has pin 7 up there in the top corner, which matches this top sheet. And right off the bat, we can see that pin 7 on the Microsoft mouse or the Logitech we're working with is the switch. And on here, it is Y2. And I'm assuming that Y2 is going to be the same as YB, because there's also a Y1, which I'm going to assume is YA, and yeah, YB. So right off the bat, we can see that that's different. And if you look at all of these signals, none of them are in the same position. There isn't any pin that is the same. They completely swapped everything around. Now my idea would be to open this mouse up, because I don't want to cut this cable. Obviously I could cut this cable and rewire the signals. I'd rather not do that. I'd rather just open this mouse up, which hopefully will be easy with these 2 screws. And then hopefully we can take the loose wires that are inside that go to the connector to the PCB that's in there. There's a PCB, and we can swap those around. Maybe I can de-pin the connector and rewire it, or I might have to cut and resolder those connections together. De-pinning would be preferable, but I might not have the right tool to actually de-pin the little connector. Now looking at this, it seems relatively trivial. Everything should be swappable into the correct position, but there is actually one potential issue, and it's this: E, chassis ground. That is the shield on the connector, this part that's metal. And what I'm worried about is that inside the connector itself, they have bonded the ground pin, which happens to be pin 9, this top corner, to the chassis ground. Well, that could be a problem, because if the physical pin 9 in this connector is bonded inside this molded connector to the shield, and that means it will short this Y input out to ground, and that will mean the mouse can't possibly work. So my only hope is that this is not connected to any ground at all, or if it is, the shield makes its way along the cable into the mouse, and that shield comes out and is connected to the PCB on the ground pin, and it's not actually bonded inside this connector. All right, so one thing we can do is we can use the multimeter in continuity mode. There we go, and we can check pin 9 to chassis ground. Now, when we take a look at this, there's pin 9. It's with the 2 pins on the top row, and it's actually going to be reversed. Notice the 2 pins are on the right side, and here they're on the left. This is the connector that's on the computer or the card that this would plug into. Right, so let's see if pin 9 is actually grounded to the shield. Oh, it doesn't seem like it is. Excellent. And just to make sure that was on the right pin, pin 9, ground, that's the 2 pins on the top row. So of course it's going to be on the right side here, and nothing, just to show that it's in continuity mode. If I touch it, it beeps. So I guess this shield is just not grounded at all on this Logitech mouse. So here's a little spreadsheet that I made up that just shows the 9 pins on the mouse connector and how all the signals are all swapped around. The one thing I don't know is that on this that I found, and any other documentation I could find, it always listed the buttons as button 2, 3, and 1, and it never really told you which was the middle button. Meanwhile, on the Archimedes, it says left, middle, and right. Now, it is my assumption that this is going to be mouse button 1, this is mouse button 2, and that is mouse button 3. I think that's by the fact that the original version of the bus mouse only had 2 buttons, and the left button was always mouse button 1, and this was always 2, and 3 was added after the fact, or the middle button was added after the fact, and that's why it's called 3. I think when we open this thing up, though, we should be able to just trace these signals. I think they literally just make their way directly to the connector. And I'm not 100% sure if when you push the button, it grounds the signal. So if we look at like switch 1, pin 6, does pushing the button just ground pin 1, or does pushing the button pull it to 5 volts? I think what I can do is once we open this up, I need to figure out which colors go to which pin on the bus mouse so that I know how to rearrange them. And that means I'm going to have to very carefully probe this and check for continuity through to the wires that are inside the mouse. All right, enough talking. Let's just open this thing up. It looks like there are 4 screws. There are 2 under this warranty void sticker. Tells me that no one has ever been inside this mouse, which is that a good thing? Maybe. Oh no, the warranty is void on my 1980s mouse. You don't say. There's the inside of the mouse. This will need some cleaning. Interesting, there are 2 springs down there. I'll take those off. I don't want them to get lost. I don't know what those do exactly. There's our inside of our mouse, and yep, that's looking really nice and clean. And you can see those switches. Anyone recognize what brand of switches those are? Nope, I don't. Hopefully they work well. This is great. This connector will be really, really easy to repin. That'll be no problem whatsoever. Oh, that's awesome. Okay, first thing I want to do is I'm going to take these upstairs and just, well, give this a little clean. I noticed that this button is a little sticky, so something obviously got spilled in here. So a little scrubbing with some soap and water should really help clean this up. And this is why I took out these little springs, because I didn't want to lose those. In fact, I'll just put them up there for safekeeping. Okay, I'm just going to go give this thing a quick wash. Right, so first step is I'm just going to mark this so we know which way that connects to the PCB. I mean, it's going to be kind of obvious, right? Well, we're going to be completely rewiring this. So I'd just like to know, well, exactly how this goes back on. All right, so let's see here. Let me get my multimeter back out. Let's figure out this whole button situation. Notice there are no ICs on this thing, and that's because it's just using these transistors to convert the output of the rotary encoders, these two encoders, which use infrared LEDs and a little optical sensor. And as you turn this, you see those little marks there? It basically breaks the beam, and it does it in alternating patterns, and that's the way with the quadrature encoding it's able to tell which way this is running. So because there's no ICs, we know that the output of these buttons just goes directly to the connector. And look at the back side, we can basically see that that's the case. So this is one side of the switch that is going to the connector, and then this is going to be the common signal. So it's either the ground or the 5 volts. Actually, we'll just connect that back up. So what I'm going to do is I'm going to clip onto the multimeter probe. So there's our continuity, which goes to that pin on the multi-pin connector. And let's just figure out if that goes to the ground pin on here. It does. There's ground pin. And on the multimeter, let's just show you what I was seeing. It's less than an ohm. And on the bus mouse, 5 volts was pin 1, which I'm assuming is this pin there. Let's just grab our printouts. Pin 1, yeah, so it's the opposite corner from pin 9, the ground pin we were on. And we can just see that, well, that's the ground pin. There's pin 1, definitely has nothing. Right, so next up, I'm going to clip onto the buttons one by one and figure out which of them is which on here. So we have switch 1 and 2. My assumption is switch 1 is going to be the left mouse button, and we'll be using this pin out right here, top one. So pin 6, which I think is going to be left mouse button, it's the one right under the ground pin. This is the left mouse button, 6. That is pin 6. So left mouse button definitely is pin 6. And then these two pins, that's the middle button. So let's see, 6, 7. That is pin 7. Middle mouse button. And finally, we're on the right mouse button. It's obviously got to be pin 8, which is this one right here. It is. Let me just check the other ones. Yeah, no continuity. Okay, cool. Right mouse button. Well, look at that. That actually tells us that that one is already correct, but every other pin needs to be swapped around. So, okay. Now, I didn't notice that these switches are actually connected to both ground and 5 volts. Let's get a little closer and show you. So these are the 3 pins that go to the switch. Now, I think what's happening is there's probably a 5 volt pull-up resistor, and when you push the switch, it probably grounds it. So I think I was assuming that this thick trace was the ground pin, which is the middle on all of these. In fact, see if we go to these, see this is all connected together, these middle pins, and that went to here, which when we look at the pin out, pin 9 was ground, pin 9 was this one right there. Cool, and definitely it's not connected to the shield, it's just there. Okay, so that pin is ground, but looking at the 3 pins on the switches, this rightmost pin, well, on the bottom side, this is all connected together. And that one there, let's see if they are actually connected together. So yes and yes. So it's my assumption that this is going to be 5 volts, and it goes to that pin right there, but it also connects to the signal wire through that resistor. Now if we look there, we should be able to see the value of that resistor, 4.5K. Okay, hold on a second. Okay, so when these are pushed down, we're getting that resistor drop. When they're not pushed, they're actually shorted. So 17 ohms. We can tell that these are a little dirty, these switches. Yeah, okay, 4.5K when they're pushed. So that means in the idle state, these are actually connected directly to 5 volts. If we switch to the ground pin, so we're really high resistance there. If I push the switch, wait, what's going on here? Okay, I don't think that's, okay, I think this switch is actually bad because I'm getting all sorts of wild readings on there. Let's switch to the middle button. See how this one is working. Okay, so in the idle state, it's nothing. When I push it, yeah, there we go. Okay, so when you push these switches down, it actually connects the ground to the signal. Otherwise, normally it's the 5 volts that's connected to the signal. There it is. I push the button, the middle button. There we go. Now we're at 4.6K. I think what we have figured out though is that this switch is not working correctly, because right now if we measure this, there's mega ohm and I'm pushing it. It's not working correctly. This switch is definitely bad. Yep, look at these readings all over the place. All right, so we have a bad switch. That's not good. Glad I checked that because I would have been thrown for a loop. Let's check this one over here. Okay, we're in mega ohm and I push it. That one's not working well either. I swear the only one that is working properly is the middle button. All right, 10 ohms, okay. Maybe deoxit in those switches. Let's do that. We're gonna use the Mega Strong Deoxit D100. Looks like we have a small hole, so I'll put some in the hole, a couple holes. And maybe I'll put some down the switch hole. Try to at least. And now we'll just exercise these switches a whole bunch. In fact, I'm going to bang this around to try to get that deoxit to go into the switches. All right, did that help at all? No. That's annoying. Maybe, kind of, not really. It's actually a little bit better, but not completely fixed. Oh, there we go. Finally, we're getting a good reading. So if I switch this to beeper mode, actually will help us because when I push the button, it'll beep. It should beep. Okay, that is definitely better than it was. Definitely better. Let's try this one. Oh, that one was always working, so no problem there. And this one. Nice, okay. I think the deoxit did the trick. Yeah, that stuff is magical. It really is. Okay, well, anyways, we figured out which switch is which. So we actually have one that's correct with the wiring. We know that the ground is not bonded to the shield, so that's great. And at this point, I need to figure out what color wire goes to which pin on the bus mouse so I can create a little conversion chart so I know that it, you know, for instance, like this white wire, and it was hard to tell on the camera, but that is a white wire, where that goes. So I'm gonna need to move it from that pin, whatever that is, to the appropriate pin over here. So I'm gonna spend a moment to write down all these colors, and then I will tone out each one of the colors to the connector, and we know the pinout of the connector, and then that'll allow me to figure out what colors go to which on the new pinout. I hope this makes sense. It'll make sense once I'm all done with this process. I'll be right back. Okay, there's our color-coded pinout. The shield is pin 10. I unplugged it from the mouse, by the way, because remember these pull-up resistors and these switches connect the various signals together. So this allowed it to be much easier to probe all the signals just to make sure I wasn't getting any bad readings. So now that I know which colors go to which pin on the bus mouse, I need to figure out the translation table on how to swap these around so that they are going to be correct for the Acorn. All right, here's our new sheet. Hopefully I've done this all correctly. So these are the wires and the pins that are on the mouse right now. Well, translating the colors over to the Acorn side was pretty easy. For instance, the XB signal, which is gray on pin 3, now needs to be on pin 1. The left mouse button, which was pin 6, the black wire, now that needs to be on pin 2, and so on and so forth. And now that I know, after doing a little bit of checking with the multimeter, switch 1 is left, switch 2 is middle, switch 3 was right. So what I did to help me rewire this, I wrote down the wire colors for the existing configuration. So it's white, green, yellow, light blue, and black. I know it's hard to see, but there's a black wire there. And on the back side, the shield is at the top, that's this thick one, then red, orange, gray, and brown. That matches. And then I just used this translation that I've done. So we know the black wire on the existing connector needs to become the white wire. So there it is, white. And light blue, which is pin 7, needs to become the green, and so on and so forth. And then the only two that don't change are shield and red, and that's because the right mouse button, pin 8, is the same on both. So what I need to do is just depin this and rewire it so it matches what we have here. And theoretically, that should mean that when we plug this back into the Acorn, we should have a working mouse. So these are very easy to depin. I just recommend using something like tweezers to grab the wire. And then you can use a little X-Acto blade or something to lift up the little pin. And then that comes out. So there's our white wire depinned, and I just need to do that on all of them, except I'll leave the shield and the red wire in place just to give me a frame of reference. and I'll just reinsert them like how they should be for the Acorn, and there we go, rewired. There we have it. It's all rewired. Incidentally, I noticed that the orange wire was actually pink when I looked closer. This wire right here. It's just hard to tell under the lights down here. So the new configuration, remember the shield is up there and the red wire is gray, yellow, black, which is there, green and white. And when we flip this around, orange, aka pink, there's light blue, then brown, which is a little bit hard to see, red, and then the shield. So theoretically, this has been rewired. So we can connect this back up to the mouse and we can give this a check. We'll use the continuity mode and we'll check the 5 volts, ground, switches, stuff like that. Those are all things we can easily check with the multimeter. And we'll just go right to here. We'll look for pin 4, the one under there. That should be the ground pin. There we go. That's ground. And then we know that the rightmost pin, looking at the bottom side, is the 5 volt pin. And again, checking this directly, 5 volts right there, pin 6 under the 2 pins. So right here. Uh-oh. So I have that connected to the X1 pin. Okay, I made a mistake, obviously. It's why it's good to check this stuff. Okay, the white wire should now go to pin 6, 5 volts. Oh, that's where the black wire is. What did I do? So I did my conversion incorrectly. I need to check my work. So to do this conversion properly, you look at the signal. So 5 volts, that's right here. 5 volts on pin 6. And pin 6 used to be the black cable. So that means the black wire should be in the position where the white wire was before. So not gray, but black. And obviously, I think all of these other ones are probably going to be wrong. So I need to kind of go down the list here and redo these. All right, so here is the corrected pinout. So that was the wrong one that I had and the right one. What I needed to do really is define what all the pins on the PCB are. So left, middle, XB, 5 volts, and so on and so forth. This is what's actually on the PCB. So what you need to do is to map this. So for the left signal that comes out of the PCB, so that's this pin that's on the connector, that originally was going to the black wire. But the reality is that doesn't really matter. I know that on the Acorn, the left signal is on pin 2, and I know pin 2 maps to the yellow. So I removed the colors on this side, which is completely irrelevant. You just need to know that the left signal, which is this signal, needs to go to pin 2, and I know that pin 2 goes to the yellow wire. So that's the new mapping. Middle button is pin 3 on the Acorn, and that goes to the gray wire, and that's the gray wire. XA is on pin 5 on the Acorn, and that goes to the green wire because I know the green wire on pin 5 is the same. So that's green, light blue, black. 5 volts is pin 6. That's the black wire, so on and so forth. The bad wiring I had brown and orange. Well, that was actually correct. So if we look at ground, that's pin 4. That's the brown pin. And orange, which is YA, pin 9 happens to be orange. So white is the only one that was wrong. So I had light blue there. And now it is supposed to be white. So XB, which is right there, pin 1, white. So, okay, so I went ahead and I repinned this again. Let's plug this in and we'll still do our little bit of testing, at least with the 5 volts in ground. We just want to make sure that those signals are correct. Okay, so I know that the middle pin is the ground pin, and all that's really relevant is this. So we're looking for pin 4, which is the one under the space. So that's correct. And then I happen to know that that pin there, that's the 5 volt pin. And if we look here, 5 volts should be pin 6, so under the 2, which is this one. And there we go. That looks good. So let's check this middle mouse button as an example. The signal wire is that one that goes to there. And we're looking for the pin that's right underneath the single pin, which is this one. And what happens if I push the button? Should be no change. Yep, no change. Now, if we look at the other buttons, like right mouse button, which is this one, there will be some continuity. But you'll know that you're not on the right pin. If I push the button, see, the continuity goes away. I know, sorry, you can't really see what I'm doing. But we have continuity, but when I push the button, it goes away. And that's because, of course, these are connected together with ground and 5 volts, and the signal makes its way through the other stuff. So if we look at the left button, which is down here under the 2 pins, so let's see, 2 pins, that means it's this one. Oh, multimeter shut off. That should come back on in a second. There we go, we have continuity, but again, if I push the middle button, it goes away. So that confirms the middle button one is correct. So let's do the right mouse button. That's pin 8 right there. So it should be the same process again. So there we have continuity, but if we push the button, there should be no change at all. and there isn't. But same thing, if we go to the middle and the left, then we will get that change. So I'll go to the middle button and there's continuity, but if we push the right button, there we go, continuity goes away. Okay, so I'm confident that this rewiring has worked at least for the ground and 5 volt, which is critical, and then we know that the buttons are correctly mapped. As for the X and Y stuff with the Y1, Y2, X1, and X2, well, maybe those are reversed, and what would happen is when we go to move the mouse pointer will move the wrong direction. Right, so it's time for testing. I just need to blow any additional water out of here, although it looks like it's dried pretty well, just sort of sitting here off to the side, and get this thing back together, and we'll test on the actual Archimedes. One thing you have to be careful about when you put this back together is make sure the wires are not underneath where the screw thing will go. You don't want to get these wires crimped in there. When you put screws like this back into plastic, you should always go backwards until you feel a little click, and then it should turn easily. And sometimes there's 2 clicks. Let's see, one. Let's see, we find the right click. So there's a click. Oh yeah, there we go. That goes in really easily now. You don't want to create new threads in the plastic since this is just self-tapping stuff. One thing you may notice on the bottom here is this little pad is off, and there's also some gunk in here. So some tweezers go a long way to kind of cleaning that out. These are just little Teflon pads to help this glide more easily. I'm not sure I'll be able to fix this one, but it's not like I'm going to be doing like heavy all-day computing on this thing. Oh, there we go. Okay, we got that off. I'll have to find some new adhesive to reattach this pad. For now, we'll just keep this in a safe spot. Luckily, the little wheels inside there are nice and clean. I don't think this mouse was used a whole lot. Yeah, I mean, the fact that the buttons don't look worn out and we don't see like a thumbprint on the side, so I don't think this was used a whole ton. I'm just gonna give this a wash upstairs with a little Brillo pad just to kind of give it a little more grippy texture. A little soap and water goes a long way to kind of rejuvenate these balls. There we go, a little scrubbing with a Brillo pad, a little soap and water got off that hard shiny layer. This feels a whole lot grippy. This should work a whole lot better. I used to do that back in the day when I used ball mouses all the time. You know, I just realized getting the Archimedes, I should have tested this before I put this all back together. It's not a big deal to take this apart, luckily. It's not like it has clips or anything, but I probably should have tested it before I put the thing all back together. Okay, moment of truth. Let's plug this into the mouse connector. There we go, nice firm connection. It's not gonna fall out like that adapter. I'm gonna turn on the computer for the first time. Hopefully no magic smoke comes out. You never know. I'm pretty sure I got the 5 volts and the ground hooked up correctly, but well, the printout's on the floor. If that printout was wrong, the actual pinout for the Acorn, well, what can I do? Let's turn this thing on. Nothing seemingly happened bad. System is booting up here. I had the R key held down. Okay, well, it works, but it is wrong. So when I go up, it goes down, and when I go right, okay, right and left are working, up and down are not. How about the mouse? Middle button, that is good. I'm gonna say the left button is working since that does a selection. Actually, I'm not even sure. Oh boy, this is hard to use. It really messes with your brain because I have the X direction. Obviously the 2 wires are swapped around. Let's see if I can open the paint program. All right, so what I'm not sure about is the left and right mouse button may be misconfigured because it seems that right clicking or left clicking on something has the same effect. So I opened the paint program, if I can get down here. Wow, it's difficult to use because it's all backwards. Okay, here's our paint program. So that's, it's so difficult. That is with the left button. Okay, right button doesn't do anything in here. Middle button is working, it brings up the menu. What I need to do is I'm gonna turn off the computer and I'm gonna switch to the mouse with the adapter. I just wanna see if it's the same thing, where the left button is what draws and right button doesn't do anything on the canvas. I'm not familiar enough with the Archimedes to know if that's the intended behavior or what. All right, there we go. We have the optical mouse hooked up. Obviously, I'm gonna have to open up the Logitech and swap around the X2 pins. Okay, everything is working properly now. Let's open up the paint program. Yes, okay, so that is the left button and the right button doesn't do anything. Okay, cool. That confirms the mouse buttons are connected correctly. The Y direction is connected correctly. It's just X that is somehow swapped around. Yes, everything is working as expected. So the question is, what did I do wrong? So XA is the yellow wire and XB is the gray wire. XA yellow, XB gray. XB was pin 1, which should be white. So XB, white. And then XA is pin 5. That was the green wire. XA, green. Okay, well, I think I did it right according to this sheet. Let's double check what I have on here. Oh, that's right. So it had X1 and X2. I just had to guess what was what. I just thought that X1 was the equivalent of XA. So that's why XA is labeled as pin 5. But notice Y1, pin 9, I have it as YA. So that's correct. The YA and B are right. But the X1 and 2 are actually reversed. So pin 1, XB, X2 is actually XA. So I don't really see why that's the case. And just to double check what was happening here, so XA was labeled as pin 2 originally. XA, yeah, so I have that correct. XA and XB, XA and XB, yellow and gray. So I don't know. So all I need to do is just swap around XA and XB. So the green and white wire just need to swap positions and we'll be good. Okay, there we have it. I swapped the green wire and the white wire, which I haven't updated the spreadsheet yet, but XA and XB, green and white, I just swapped the position. So you'll notice that the green wire is next to the pink and the brown wire now. Well, labeled as orange and brown on here. So that should do the trick. And how about I test this before I put it all back together this time, like I should have done the first time. It's not working. Okay, wait a second. Wait a second. Okay, I made it worse because I thought left and right was the X direction, but it's now reversed as well. So it was the Y direction. Are my math skills just wrong? I thought X and Y. X is left, right, and Y is up and down, but I just made it worse. Oh, you gotta be kidding me. Okay, so what that means is I need to swap back those two wires, and then I need to switch the other two wires, the Y wires. You gotta be kidding me. This connector's gonna break. I've like taken it apart so many times here. All right, so I just swapped those two back. So I need to swap the orange and light blue. That should fix this thing. Okay, there we go. Pink, aka orange, light blue swapped. Hopefully now it works properly. Yes, up, down is working, left, right. Okay, there we go. Finally fixed. Finally freaking works. And we'll use a proper mouse pad. Oh yeah, that works. That freaking works. Middle button is working well. Let's bring up the paint program again. I'll channel a little LGR here. And this thing freaking works. There we go. Love it. Very nice. Middle button is working as it should. Yeah, this works. This freaking works. Ah, that's awesome. That's very satisfying, I have to say. Also, what's really interesting is I noticed when I was using the optical mouse with that microcontroller converter thing, it just felt really hard to be very precise. But I have to say, with this ball mouse, moving the mouse slowly, it's perfectly fine and very precise. There were definitely issues. Maybe it's my optical mouse, the way the acceleration works on it. I don't know. It didn't feel very good with the Archimedes. This, on the other hand, feels completely as expected, completely normal, easy to hit your targets. Oh, much better. Yeah, because I was kind of thinking that the whole mouse support on this computer sucked, but it was entirely that adapter or the mouse that I was using with it. I'm not 100% sure, but I can tell you that, well, yeah, this is working way, way better. So there's the calculator. Here's our text editor. This is a text editor. Very nice. Very, very nice. Right, what's left to do is label this mouse appropriately because we modified it and that's what this is for now. Don't use it on other things. It's definitely not a PC bus mouse anymore. It's for the Acorn Archimedes. Right, there we go. That's one modified Microsoft bus mouse, compatible mouse, modified to work on the Acorn Archimedes. I'd imagine you should be able to do this modification on any of these. So if you have an Archimedes and you don't have the original mouse, I'm assuming these are relatively easy to find, or maybe not exactly like this, but any 3-button bus mouse that has the standard in-port connector here, if it's wired up similarly inside, which I assume it will be, then you could use this type of conversion process to get yours converted. I'm going to fix this spreadsheet just to fix the 2 swapped wires, and then I'll share this out in the description. So if you want to look at this, you could do so. Although I don't think this is going to necessarily be very helpful unless you have this exact mouse. And keep in mind, I bet you there are multiple versions of this with different color wires and stuff like that. So going off just the wire color isn't necessarily the right thing to do. Use the process that I showed here by checking for 5 volts, checking for ground at the minimum, and then figuring out the rest of the signaling. I still think it's kind of funny that the Y on the mouse is actually left and right and X is up and down, but maybe that's some kind of mouse convention that's existed for all history. Also funny is that the Y, A, and B doesn't really map exactly to the Y1 and YB exactly as I thought it would, but whatever. Obviously, you could see what happens when it's hooked up backwards. It just goes the wrong way. And yeah, this process should work, to be honest, to convert any other quadrature encoded bus mouse type thing to any other system. So Amiga mouse to Atari, Atari to Amiga, Atari to Macintosh, you know, all that stuff should generally work. The only thing I think that won't necessarily work is the way the Apple II mouse works. I think that might be a little bit different. And I think the Apple Macintosh bus mouse is able to sense if it's plugged into an Apple II, and some of those will switch modes automatically, others won't. Like that platinum color one I showed earlier in the video, that does not work on Apple IIs, but I have other Mac mice that do. Why? I don't know for sure. Anyhow, hopefully this video was helpful. I'm glad to have converted this because this is so much better to use with the Archimedes. So thank you very much, Mike, for sending in the Archimedes and also sending in this mouse. I'm glad to have finally converted this over. And you'll be seeing more on this machine over on the main channel coming up soon. If not, there might have already been a video release. So I don't know. Anyways, that's it. Thanks to my supporters. Thanks to my subscribers. Subscribe if you haven't already. Comment down below, etc., YouTube junk, etc. And that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.